Okay, so index laws is all about having the same base, all right? So consider something like 2 by 2 by 2. Well, that's the same as 2 to the power of 3, isn't it? So really, all the bases are the same, which is just 1 plus 1 plus 1. So hopefully you remember all that stuff from last year, all right? So simplest way, multiply numbers together, multiply common bases together. So if we want to simplify here, 3 times 4 is 12 times a to the power of, well, we've got a 2 plus 3 times b to the power of 3 plus 3. So we simply end up with 12a to the 5b to the power of 6. All right. Um, with divisions, it's a similar process. I think if we can find common factors first, that's the easiest way. 4 goes into 4 once, 4 goes into 8 twice, 4 goes into 16 4 times. So if I collect my numbers together, if you like, I've got 4 times 1 over 2 times a. What are the powers on a? I've got a to the 5 plus 4. Now divided by a to the 1 means I subtract that 1 times b to the power of, in brackets, we'll put a 1 plus 3, and we've got a 1 on the bottom, which means we subtract 1. So 4 over 2 is 2. A, 5 plus 4 minus 1 is 8. 1 plus 3 minus 1 is 3. Okay? All right. If we have power or brackets raised to a power, we multiply the powers together, because don't forget that's the same as having b to the 3 times b to the 3, which is just b to the 6. Yeah? So I get b to the 6 times b to the minus 2 if I multiply 2 by negative 1. And that's simply equal to, add the powers, b to the 4. So if we slide our examples up, same thing, multiply, expand my brackets first. So I'm going to end up with a 2 cubed a to the 6 b to the 9 times 3 to the minus 2 times a to the minus 2 times b to the minus, what's that, 8. So the 3 to the power of minus 2, let's just bring it over here first. That's 2 to the 3 times 3 to the minus 2. Get my numbers together. A to the power of, I've got a 6 minus 2, which is 4. B to the 9, what's that? That's a minus 8, isn't it? Makes it a b to the 1. So I can write that as 2 cubed, which is 8, a to the 4b over 3 to the power of minus 2, which is 9. All right, so remember our negative indice, to make it positive, we bring it into the denominator. If I have a fractional power, or a square root, I should say, the nth root, it's a to the 1 on n. So the square root of a is a to the half. The cube root of a is a to the third. So it doesn't matter whether they're fractions or whole numbers, we treat it the same. So let's go 3 to the 1/4 times 6 to the 1/2 times 2. The fourth root of 2 is also a quarter. Let's simplify, it's 16 a little bit first, hey? So what if we could write 16 as 2 to the power of 4? And that's all to the power of 3/4. Now, none of these have the same bases, the 2, 3, and the 6 in the numerator, but 6 is obviously 2 times 3. So what if I write that top line as 3 to the quarter times 3 to the half times 2 to the half, which is the 6 value, times 2 to the quarter over, well, 3 times 4 is 12 over 4 is 3, so that becomes 2 cubed. And we're running out of room. If I come across 3, I've got 3 to the quarter times 3 to the half, so that's 3 to the power of a quarter plus a half times 2 to the power of a half plus a quarter We've got a 2 on the bottom, minus 3. So a half plus a quarter is a half plus 2/4, so that's 3 to the 3/4 times 2 to the power of a half plus a quarter. We just decided that was 3/4 minus 3. So 3/4 minus 3, if I come over here, 3/4 minus 3 is 3/4 minus 12 on 3. Whoops, 12 on 4, which is negative 9 on 4. So there's my answer. Perhaps to write everything as a positive index, we might write it as that. Okay, so look, it is a little bit messier with fractions, but it's the same principles. It just means we have to add and subtract fractions or negative numbers. Let's come up here for part B. 32, write it as the simplest base. That's 2 to the 5, all to the power of a quarter, times 12 to the half. So given what we just did, 12 to the half is 4 to the half times 3 to the half times 4 to the 1/3 times 3 to the 1/3. So that one there is root 12. That one there is a cube root of 12. All over 16, let's write that as 2 to the 4 to the 1/4. So that is equal to, I get 2 to the 5 on 4 times, well, 4 is 2 squared. I get 2 squared to the power of a half times 3 to the power of a half times 2 squared to the power of a third times 3 to the power of a third, all over 4 times a quarter is 1. I go to room again, equal to, I get 2 to the 5 on 4 plus, what's that? 2 times a half is 1 times 3 to the half times 2 to the 2/3 times 3 to the 1/3 all over 2 to the 1. So let's get all our 2's together. 2 to the power of 5 on 4 plus 1 plus 2/3 minus 1 times 3 to the power of a half plus a third. Sorry about scrunching up. So I get 1 minus 1, so that's okay. 5 on 4 plus 2 on 3, so make them both 12ths. So I get 2 to the power of 15 plus 8, which is 23 on 12, times 3 to the power, make them both 6's. 3 on 6 plus 2 on 6 is 5 on 6. All right, so yeah, it's a little bit messy. It's a little bit more involved, I guess, simply because we've got fractions in there, but we just got to aim to apply the laws properly.